sign on the board?
Yeah.
You can still see it though, can't you?
There's a triangle.
That's
There's
fine.
an eye.
It's fine. Let's see how it works. Yeah, it works fine. Okay. So we're going to look a little bit more at orbits today. So just to recap from the last class, what's the force for something that's traveling in a circle?
MV square
W.
Well, I think no. Well, m for sure, and then v squared over r.
Or we have another one.
And we have another one. Yeah.
M angle. MW r square. W squared.
Omega r squared or m.
No. Omega squared.
Omega squared or. And we also have omega equals v over r. And what else did we have? L equals r theta.
Yeah.
Yeah, that was all our formulas, wasn't it?
So
Oh, and we also did one.
Just a minute, Mrs.
Yeah.
L equal r theta.
Yeah.
If he need L and he give us the r, and the angle is 45.
We change it to radians.
Yeah. Would be by over something, not by
What is also the force for two masses? The gravitational attraction.
G.
G. M for the Earth, for example.
M for the human or anybody, r squared.
Anybody else, yeah.
R squared.
And
R squared.
yes, r squared. And we have G equals 6.67 times 10 to the minus 11. And here we're using Newton, meters, kilograms, and seconds. Our usual units. Okay, so that was all we really did last time.
Just
You want to recap these? Sure.
Yeah, I know, but cover for the next time. I'm not losing anything. Just right away.
You are exactly right. You're only gaining.
I'm not losing anything.
Sorry.
It's just kind of
Yes?
The G equals 6.6.
6.67.
Okay. 6
Is it an exact of theta?
Huh?
Is it an exact number?
Of theta or of G?
This is even.
Just a sec. Yeah? What?
2 over 3.
2 over 3.
Yeah.
Oh, here. Are you saying is it exactly 6 and 2 over 3? No. No. It looks like it, but it is not. Yes, Mustafa.
That's this force for what? The first one?
Circular motion force. Centripetal force, but circular motion is fine for us. Okay.
Still, my people are writing. Can you do that yellow thing to here as well?
Huh?
Can you paint here to yellow?
I can. Why?
Just do.
Okay. Where now?
Yeah, go on like
Here?
this. Yeah, like this.
That's why I'm. I don't know. They must want to do something.
What do you want the triangle for?
Here as well.
Oh!
And here is something you can see now.
No, coincidence.
What?
No, coincidence. It's a symbol of a secret society, but it's a coincidence.
Well, we're on the science, so it's okay.
Coincidence.
We're not in the church now.
Okay. Now, are you ready to do some more examples using
What is
these?
what is NMKGS for what?
Oh, I'm telling you, this is the
the
units. Yeah. Okay. Now, let's have a look at some examples, okay, of using this.
For angles is radian.
Always, yeah.
Not degree.
Oh, no, you can use degrees. Radians is normal.
Yeah, please, can you give us an
Yeah,
example
we're doing-
for these?
Yeah. The mass of the sun, so here's our first example. The mass of the sun,
Sun, okay.
its mass equals 2 times 10 to the 30 kg.
Okay.
The Earth moves in a circle, or nearly a circle, and the radius of the circle is about 1.5 times 10 to the 11 meters.
He can give us the L and the length and the theta, and we have to find the R, right?
Oh, we could, yeah. Yes?
This is 10 over 10 power.
11, yeah.
Okay, 11.
And the question they want answered is what's the speed?
Speed.
Yeah, the V.
And the V.
So what's the formula for V?
And
V
the
square.
angle V.
Omega R. So we can say
Omega
V
equal-
equals omega R.
Yeah.
Now we want to find the omega. Omega,
It's one circle, so. two
yeah,
pi.
one orbit. So it's
Two pi
2 pi per year.
per year.
Yeah.
It's written there.
No, this is our knowledge.
Okay.
You know, the Earth takes 1 year to orbit the Sun. So that equals 2 pi per 365
Days.
multiply 24, yeah, days, hours, minutes, seconds. So can you type that number in, please?
2 pi, so 2180 multiply 365 multiply 24 multiply 60.
Yeah.
Just wait up, please.
Yeah, in 1 sec. Here, maybe just
Thanks.
2 pi per
Will be 1.135 10 power 10.
one.
Just
1.13526.
Yeah, give me.
Ten.
start. Yeah.
1, 3, 5 times 10 to the 10. Thank you. Oh! Close. I know, I was thinking that too.
Close the coffee as well.
Yeah. Alright, 2 pi per this many seconds. So now can, yes?
Isn't it 3.1153?
I don't know, they're typing it in on the calculator. 365 times 24 times 60 times 60.
That's 3.153.
Oh. Do you check your calculation again, please?
No, I'm multiplying 2 pi with the O.
No, just the seconds.
Just listen.
Yeah, what is it, Albert?
3153600.
1.1.
Wait. Albert has it here. Let's get it from Albert.
3153.
Hey, I got something different.
Yeah, 6.
Shh.
Yeah.
3153.
6. 30.
Oh, sorry, times 2 pi.
Not yet, no.
Yeah.
Oh, sorry.
365.
Now, it's 2 pi per this many seconds. So can you do 2 pi divided by this, please?
5 by
Divide.
2 pi divide this number.
Okay.
Why divided?
Because we want it per second, not per 31 million seconds.
Uh-huh.
1.1.
Yeah. Maybe it's easier. So you have about 1.14 times 10 to the minus 5.
Yeah.
Yeah.
That's the angle.
That is the omega. So what this means is per second. So what is this going to be? 0.00001 about.
I'm not going to write this.
No, leave it like this.
Yeah, sure.
So anyways, the point here is per second, the Earth's angle increases by this many radians. So every second it moves a tiny little angle. Great, so now we can calculate the V.
The
V equals
multiplied by-
omega times R.
So we can get the R.
Yeah, so it'll be about, it's going to be something like about 1.7 times 10 to the 5.
7 to 6.
Yeah, what did you get?
I got 10.6, but that's 1.7 multiplied by 10 to 6.
10 to the 6? Oh, sorry, the radius is
Yeah.
power 11. Sorry, yeah.
1.7 10 to the power 6.
Yeah, well, if you want in
1.7
7 to 1.
721
What
times 10 to the 6
What's your
meters.
Steven is 7 to 1.
71.
71.
What's after the 1?
1.721.
No.
Okay.
This
It's
is
my
in
accent,
degree.
sorry.
The pi is 180. So multiply 2 multiply
Yeah.
180. Divide by the answer. Just try again, but 2 multiply 180.
So we don't use pi.
No, you use by. if
No,
you
no,
want.
use, yeah, hang on.
That was an
Wait. We're all getting very confused here. Just stick with radians so we can all do it the same way. Yes.
It's 1.71.
Yeah,
10
sorry.
over-
It's 1.7, I'm running out of space. It's 1.71 times 10 to the 6
Okay.
meters.
This is given. How to
Here,
translate to
I'll write it on the next line.
Yeah, right. It's 2 multiply. Where's by? Okay.
How did-
Equals,
how did
wait. 1.71
No,
times 10 to the 6 meters. Yes, Jing Dong.
How did you get the 1 second?
Which one?
I mean here. Here, 1.
Oh, this here?
Uh,
This here is given in the question. You're
Oh,
told
yes,
this.
yes.
This is, if you want to look at it, there's Earth, and there's the Sun. There it is. And it's going around like this, and here is the or,
Oh, yeah.
and here is the M.
I know. And please go up.
Go up.
Yes. And the F means the stress of.
The force.
Oh, yeah, yes.
The force.
Is it gravitational force?
Gravitational force.
Gravitational force, okay.
And oh yes, and what's here stand for?
This is the mass of the big object, like
yeah.
the Sun, and this is the mass of the smaller object, like the Earth.
Earth.
Yeah. So like this one,
Oh,
be
yeah, yeah.
Sun, Earth, or Earth, Moon, or Earth, person.
And what's here stand for?
This one here.
Just here.
Oh, here.
Yes.
V is velocity. It's like speed.
Oh,
How fast? Actually, sorry, it is here speed. Speed. For the V. Yes. Yeah, go ahead here.
Jing, don't worry, man. We will repeat it on.
Yeah, maybe you haven't seen this bit before. Have you seen this before?
yeah.
Yeah. So the V is speed, the R is radius,
Yeah.
and the omega is how quick the angle changes. You know?
Yes, and this way means speed. That means it circles.
Which one will we say again? This here. This here is speed. How fast?
The speed of the Earth.
The speed of the Earth. Yeah.
Oh, yes,
yeah.
I know. Okay.
Oh, sorry guys, I made a little unit mistake. It's not meters, it's meters per second, because it's speed.
Oh, yes.
Okay.
Yeah, what were you saying, Albert? Use pi on your calculator, 3.1415926. Oh, did they put in the wrong thing? 2 times pi divided by 31536,000. Ah, you guys, hey, you calculated the omega wrong on your calculator.
What?
It should be, you should type in 2 pi on your calculator.
So we did.
Well, I got a different answer here. Check it again. 1, 2, 3, 4, 5, 6. So it's about 2 times 10 to the minus 7. Okay. Guys, look here, please. You made a mistake on your calculator here.
Who is that retard?
Hey, now be nice. Are you pressing 2 pi though?
Yeah, because go upstairs.
Oh, sorry.
No, press, yeah.
No, 2 pi. No,
Okay, 2 multiply.
no, press the actual pi button on the calculator.
Because this is degree. Because.
But I said to use radians.
What's the difference?
Quite different.
No.
No. This is it.
Yes?
Hopefully the I use the radian and degree one. There's no difference in answer.
Yeah.
Oh, maybe it's because they already used pi, I guess, that's why. They don't need to do it in radians.
Look, if you put the calculator in degree mode or radian mode, it doesn't matter. But if you're using pi, you must use pi on your calculator. If the formula has pi in it, you use pi on your calculator. You're not allowed to change that. So we need to recalculate here. Omega r, which is 2 times 10 to the minus 7 times r, which is 1.5 times 10 to the 11, which equals 3 times 10 to the 4
Yeah.
This is
meters per second.
The difference was 1.9 power and 10 power minus 7 or 2 multiplied 10 minus.
Are you asking about this piece? Oh, jeepers. Are you asking about this piece?
Yeah, if it was 1.9 to 10 power minus 7.
Oh, yeah, no, that's fine. I was being a little bit lazy. I rounded it off to 2. But, it, like, I mean, I'm pretty sure they want this at the back. Let me see. 10C, first question.
Oh, let's do another one.
Yeah.
Quicker if you just,
Yeah.
you know.
Can we go to the next one?
Yeah.
Okay. So now we want to calculate the time it takes to do one full loop. Okay?
Yeah.
Did I give you the formula to calculate time? I don't think so.
Zero.
Period.
Yeah. Well, here's a new formula for you. The time to do one loop equals 2 pi over omega.
For what?
This is the time to do one full loop. Okay?
Yeah.
But sure, we already have the answer for this. It's going to be about 365 days.
Yeah.
So, that's not very interesting
If
one.
we need it by days.
Or seconds, whatever.
Or second you have.
Here he wants it- here-
16 to like 24 to like 16.
Yeah, here he wants days. But
And it was second.
you would have to multiply it, yeah. Okay.
Another question.
Let's do another one. Yeah, let's do a car turning around a corner here. Okay. So, you have a car and it
What
turns
the-
around the
what
corner.
was?
Hmm? You have a car
Okay.
and it's mass m. And it turns around the corner. The corner forms the arc of a circle of radius 50.
So R is 50.
So r is 50.
50 centimeter? Or
50 meters here.
Okay.
What else are we told? Find the coefficient of friction if the car just begins to slip when it takes the corner at 21 meters per second. Okay, so you're told here that the velocity is 21 meters per second. I want to calculate the F force. So what's the formula for F?
MV
Equal
M
V squared over R.
V squared over R, which will here equal M 21 squared
over R.
over 50. What's that going to be?
21 squared. It will be 8.82.
8.82 exactly?
Yes.
Perfect. So equals 8.82 m. Okay? Yes? That's straightforward, I hope.
Yes, sir.
Now, what happens here? Here, I'll scroll up a little bit. There's all your information. So what happens here is, here's the car. Imagine I'm looking at the car straight on.
Another question?
Oh, well actually, no, same question. Actually, imagine I look at the car at the side for the moment. Here's the front of the car, and here's the wheel.
Okay.
What happens if the car is on ice?
It will.
Will it move or not? It won't move, it keeps spinning. The wheel spins, right? If it's on ice. And if it's on normal ground,
It will move.
it'll move. And if it's on wet ground,
What?
if it's on wet ground,
It will move, but not that speed, that same.
Yeah.
like R.
so in other words, if you look at the tire, let me put a little dot on the tire. When the car goes this way, what way does the dot move? Goes down this way, right?
Yeah, clockwise.
So the wheel is actually turning like this way, clockwise. So if the force is going this way, which way is the friction going?
This way.
This way.
Yeah. So it'll be cancelled or equals.
No, what happens here is, my point is, the friction is what makes the car go forward.
Mm-hmm.
The friction. And they want you to calculate what the mu is.
Oh.
Yeah, now how do we calculate it? Well, firstly, what is the formula for friction?
It's no.
Mu times R.
Yeah.
Yes?
Yeah.
That's for friction.
Yeah.
Now,
We have the friction. We have
the car's weight is, what's the weight of the car?
mg.
Mg. And what's the R here?
Oh, same.
R will equal mg, true or false? True. So here I get friction equals mu R, but R is mg.
Mm-hmm.
Now, friction is what's driving the car. That's the force that makes it go. But what type of force is this? It's a circular force. And what did we calculate that to be?
We count 8.082.
8.82 m. What happens to the m's?
It should. Oh.
Why is M? Yeah, okay, there's M. Okay.
Yeah.
Mass.
Good, it's the mass, not meters. Yeah. So you get mu equals 8.82 over g, which is about 9.8 or 8.1 if you want. What will this equal roughly?
It's 0.89.
So about 0.9 basically, 0.89. Let's see what they put at the back.
0.9 probably because it's 89.9.
10C question 4. They use 0.9, so we'll do that. Okay.
Yeah.
Are you happy with this now?
Yeah.
You understand it?
Yeah, can we write it?
Yeah, write it down. So I think they're all like this really. So you're going to be looking at cars going in a circle, or spaceships, or planets. More problems with going in a circle. Okay. This type of question here with the planet, and this type here with the car going around the corner. These are very common questions in the exam.
What the unit of the mu?
Hmm?
Job?
Huh?
The unit of the mu.
Oh, there is no unit in fact. It's unit free. Okay, so write this down and then you can try some of these questions.
These same questions?
All the same type. I just did question number 1 and number 4.
Okay.
So you don't need to do that. So you can start at number 2. Number 2 is what we did last class. Do you remember with the satellite? And remember,
Sputnik.
the satellite doesn't move in the sky.
Mm-hmm.
So that means how long does it take the satellite to go around the Earth?
1 day.
1 day. Very good. What's the name of this?
What's
Orbital.
No,
Orbitals. No. The name for when the satellite stays in the same spot in the sky.
Radian.
Huh?
Radian.
No.
Again,
Orbital is not quite orbital.
Altitude, no.
It's a stationary orbit
Stationary.
or a parking orbit. You know the word park? P-A-R-K?
Yeah.
What's that?
Park. Parking, like park your car.
Like park your car. Yeah.
Yeah.
Stop your car.
But that's the part for the Sputnik.
No, the only thing about Sputnik was I was trying to give you a famous example of a satellite.
Why this is just 4, 5, 6, 7?
Oh, because some of the questions, the answers in the question, because it says show that. You know, like number 1, it gives you, it says show that the speed is this.
Okay. But there is no number 2.
Yes?
It's 1 day, so
I can finish recording.